In our previous video, we learned about the sandwich theorem. Today, we will be using this theorem to prove that the limit of sine x over x as x tends to 0 is equal to 1. For this proof, consider this diagram. We have a circular sector OBA here, with O being the center of the circle, and we draw a chord from B to A. So then we get a triangle OBA. Then what we do is we extend this line OA until we reach a point C. This point C is at a point where the angle OBC is a right angle triangle. So now we have a right angle triangle OBC. So here the angle of the sector is x and the radius of the sector is r. So let's find the area of these three figures: the triangle OBA, the sector OBA, and the right angle triangle OBC. So the area of the triangle OBA can be written as half into the base OA into the perpendicular height BD. So OA is equal to R. So how do we find BD? So let's take sine x. Sine x is equal to the opposite side over the hypotenuse, that is BD over OB. So that will be equal to BD over R. So now we can find BD equals R into sine x. So we can substitute that here, giving us half into R sine x. So let's find the area of the sector OBA. So you know that the area of the sector can be written as half into the radius squared into the angle. So that is half into R squared x. So let's find the area of this right angle triangle OBC. The area of this triangle will be half into this base BC into its perpendicular height OB. So BC we can find using tan x. So tan x is equal to opposite over adjacent. So that is BC over OB. That is equal to BC over R. So BC will be equal to R tan x. So that we can substitute it here. So this will give us the area of this triangle OBC as half into R tan x into R. So now let's compare these areas. So from this diagram we can see that the area of the triangle OBA is less than the area of the sector OBA because there is this additional part. So this sector has a lesser area than this triangle OBC. It is obvious through this diagram. So let's take these areas and plug into this. So area of triangle OBA is less than or equal to area of sector OBA, which is less than or equal to area of triangle OBC. So that will be half into R sine x is less than or equal to half into R squared x is less than or equal to half into R tan x into R. So from all of this we can cancel off half R squared. So that will finally give us sine x is less than or equal to x, which is less than or equal to tan x can be written as sine x divided by cos x. So now here we divide this whole equation by sine x. When we divide sine x divided by sine x will give us 1. This will be x divided by sine x, and here sine x will cancel off, giving us 1 over cos x. Now we find the reciprocal of each of these parts. So when we find the reciprocal, the sign changes. So the reciprocal of 1 is 1. The reciprocal of this is sine x divided by x, and the reciprocal of this will be cos x. But here the sign has changed. Now we apply the limit for all three. So the limit of 1 as x tends to 0 will be equal to 1. And for this, when we find the limit of cos x as x tends to 0, if we use direct substitution we get cos 0. So cos 0 is 1. So now we have that the limit of sin x divided by x as x tends to 0 is greater than or equal to 1 and less than or equal to 1. So from our sandwich theorem, we can say that this limit of sin x divided by x as x tends to 0 is equal to 1. So this theorem can be used when solving problems. We have some exercises for you in the description below. You can attempt them and also check your answers. In our next video, we will learn the techniques of solving limits related to trigonometry. Until then, take care.